This is a video on Mclaurin polynomials. The question states, find the Mclaurin polynomial of degree 4 for f of x is equal to e to the 2x. So let's first remember the formula for Mclaurin polynomials. And that says that the nth degree polynomial is equal to the summation from k equals 0 to n of the kth derivative of the function evaluated at 0 divided by k factorial times x to the k. So I like to start out by sketching a table that will help us find our kth derivative at 0. So I have 3 columns. In my first column, I have k, and since I want the 4th degree, I need k equals 0 all the way to 4. In my second column, I'm going to take the kth derivative. The 0th derivative just means don't take a derivative, and that's our function, e to the 2x. And then in my third column, I'm going to plug in 0 into that kth derivative. So if I plug in 0 into e to the 2x, I get e to the 2 times 0, and that's just 1. So now let's take a first derivative of our function. The first derivative of e to the 2x, I use a chain rule, the derivative of 2x is 2, times the derivative of the exponential, e is just itself. So I get 2e to the 2x. Now let's plug in 0. E to the 2 times 0 is 1. 2 times 1 is just 2. So now k equals 2, that means I take a second derivative, or a derivative of the first derivative, and the derivative of e to the 2x again is 2 times e to the 2x times another 2 is 4 times e to the 2x. Plug in 0. E to the 2 times 0 is 1 times 4 is 4. Now let's take another derivative. The derivative of 4e to the 2x is 8e to the 2x. Plug in 0, and I get 8. Now take one more derivative, and the derivative of 8e to the 2x is 16e to the 2x. I plug in 0, and I get 16. Okay, now I'm ready to plug in all these numbers into my formula. So what that says is that these numbers, the kth derivative at 0, should go in the numerator. So what I get for the very first term is plugging in 0 means that I take 1 in the numerator divided by 0 factorial x to the 0. And then I plug in 1 for k, so that means 2 in the numerator over 1 factorial x to the 1. And then we have 4 over 2 factorial x squared, and then 8 over 3 factorial x cubed, and then finally 16 over 4 factorial x to the 4th. And now let's just simplify. 0 factorial is 1, 1 over 1 is 1, and x to the 0 is also 1. So I get 1 for the first term. For the second term, 2 over 1 factorial is 2 over 1. That's just 2. X to the 1 is x. For the third term, 2 factorial is 2. 4 over 2 is 2. So I get 2x squared. For the fourth term, I get 8 over 3 factorial. 3 factorial is 6. 8 over 6 is 4/3 times x cubed. And then for the fifth term, the last term, I get 16 over 4 factorial. 4 factorial is 24. And 16 over 24 is the same thing as 2/3 x to the 4th. So there's my 4th degree Mclaurin polynomial. It's 1 plus 2x plus 2x squared plus 4/3 x cubed plus 2/3 x to the 4th. And I'm done with the problem.